Hi everyone. Okay, I was thinking a way to start our English medium video because if I say good morning and if you're watching this video in the evening, it will be super odd. So I just decided to go with Ibovan because the best greeting style of Sri Lankans. Okay, let's come to the topic. Well, this is a era, this is a age, or this is a time where most of the Sri Lankan students are getting used and already have been used to this online learning system, e-learning system. So as a combined maths tutor, we are also doing on combined maths online classes through our platform. You can log into it for www.siyochem.com, and that is our platform. We are doing online classes through that. So I had this desire, and I wanted to start a YouTube channel. But what made me a bit late, because most of the tutors and many university students are currently they are having YouTube channels and they are putting videos covering lessons of various subjects, combined maths, chemistry, and physics to the YouTube. They have started such things. So what I was thinking, if I also started a lesson, a YouTube channel, and put a lesson, but that will be just another video. So I just thought of doing something different, because we know that if you search for like trigonometry, if you search for like something, a lesson in YouTube, you will get a lot of lessons from Sri Lankan tutors and university students and even foreign universities. So what I thought of doing, I came up with this idea to discuss to analyze the past paper questions. Okay, because like when we come to the YouTube, there are no many. I haven't seen many videos like discussing about past paper questions. Why is this past paper questions are important? Because to me, what my belief is, if somebody have mastered in past paper questions and just think that guy, that he or she hasn't done any sums and any calculations in tubes, but he has completed all the past papers from 2000 to 2019, I'm sure that he or she can get an A for combined maths and chemistry and physics, because past papers is vital. We should do them. If we need an A for combined maths, we have to do past papers at least from 2000 to 2019. If you don't have time, you can just do from at least from 2011 to 2019, but it will be always good if you can do it from 2000 to 2019. Okay, then I'll just tell you why I'm doing this. I'm combined maths Sinhala tutor. So why I'm doing videos in English? Because the main reason is I did my O levels in English medium, but then I shifted to Sinhala medium because of this classes issue. Because at our time there were no good tutors who did math subjects in English medium. Okay, so because of that issue, I just shifted to Sinhala medium. And when I'm as a tutor, and I have tutored and I have teach students who are doing English medium, but what we say that like Gana Sinhala English Gana. But at the end, the English medium students, they have to go to the exam, they have to read the. It's true that the Gana is true, but at the end, you have to go to the exam, you have to read the question in English, and you have to understand it in English, and you have to write the answer in English. So you will be something, if you don't know the terms, and if you can't get what in my single medium video, so if you can't get what I am telling, that means that you haven't understood it, because you don't have a proper knowledge about the mathematics terms used in Sinhala. Okay, so for that purpose, I just thought, okay, then I'll do the same video in English, which will be useful for English medium students, because I was also an English medium O-level student. Okay, so well, let's get to the point straightly. Starting up, but I had this thought when I'm doing a video about past paper questions and how can I do it, like should I just discuss an entire paper, like for example, if we take the 2019 PO paper, should I make a video explaining the entire paper, making the sums of the entire paper? Then we know we get 3 hours to complete a PO paper, and when if I here explain it to you, I'll take more than 4 hours, and a YouTube video getting lengther than 4 hours, it becomes boring. And even for example, think if you only have a question in the 2019, I'm doing the 2019 question, and I get stuck in the 2019 quadratic equation question. Okay, for that, if I have just put in YouTube the 2019 PO paper, you have to watch the entire lesson, entire video, and then you have to select at what time I'm doing the quadratic equation question. So it will be, for some students it will be good, but for some students it will be like it won't be useful. So I decided to come up with unit wise questions. For example, today I'm doing the 2019 permutations and combinations questions. Like that, I will be doing 2019 trigonometry question, 2019 quadratic equation and factor theorem question, 2019 simple harmonic motion question, 2019 probability and statistics question, like that, because then I can just maintain a video between 20 to 30 minutes, and that will be an ideal time to any student who is watching this video to understand something and without being boring, without getting bored. Okay, so I think you got my idea why I started this English medium videos also. And then let's get to the point. And I'm today starting from the 2019 A levels permutations and combination question. Okay, so if you don't have the paper, the question will be displayed on the screen now. Just pause the video and then you can just write down the question and then again play it. Okay, you can see the question now. So pause now and then play after writing the question. Okay, the question says let P1 and P2 be the two sets given by A, B, C, D, E 1, 2, 3, 4 and F, G, H, I, J 5, 6, 7, 8 respectively. It is required to form a password consisting of 6 elements taken from P1 union of P2, that means P1 and P2 together, of which 3 are different letters and 3 are different digits. In which of the following cases, find the number of different such passwords that can be formed? Number 1, all 6 elements are chosen only from P1. Number 2, 3 elements are chosen from P1 and the other 3 elements from P2. Okay, let's start. So, starting from, we know the combinations and permutations question is the 12th question and the A part. Okay, then I'll write down what they have given. They have given a set about P1, which P1 includes A, B, C, D, E, and then we have the numbers 1, 2, 3, 4. And then they have given us P2. P2 consists of F, G, H, I, J, and 5, 6, 7, 8. And we are supposed to build a password using 3 different letters and 3 different digits. 3 different letters and 3 digits. Okay. Question number 1 is easy. And the main thing, I'm not doing the simplifications much because I need to reduce the time of the video. So for some, if you can do the simplification by yourself, I won't be doing it here. Okay, I won't be doing it here. Okay, the first one, all the elements should be chosen only from P1. So that means we have P1, the set, there are 5 letters A, B, C, D, E, and we have 4 digits 1, 2, 3, 4. And what we have to do, we have to select 3 letters and we have to select 3 digits and form a password. So for this purpose, first we have to select 3 letters and then we have to select 3 digits. This is only the selection process, because we know what a permutation. A permutation means we are selecting R number of items out of n number of items and we are rearranging them. That is a permutation. The number of permutations that can be we can have from this manner is NPR. We know it. And if we are suppose somebody asks us to choose, just only to choose R number of items out of n, and we know we get NCR, and that is combination. If someone asks to rearrange and we have given R number of objects, different objects, and someone asks us to rearrange this R number of objects, and we know it can be done to a factorial R number way. It can be done in a factorial R number way. This is a quick revision about permutations, combinations, and this factorial R story. Okay, now look, first we have to do the selecting process. What we have to select from P1, we have to select 3 letters and we have to select 3 digits. Okay, it's simple. So let's do selecting 3 letters from P1, which means we have 5 letters and we have to select 3 letters. The number of ways we can select 3 letters out of 5 letters is 5CR and 5C3. It is a combination. Okay, I selected the 3 letters and then I'm moving to 3 digits. Okay, we go selecting 3 digits 3 digits from P1. Okay, here we go. And we have 4 digits. We have 4 digits, and out of the 4 digits, we have to select 3 digits. That means out of 4, the number of ways we can select 4 digits is 4CR. Okay, so that is the selection process. This is the selection process, but selecting 3 letters from P1 and selecting 3 digits from P1. We get 5C3 and 4C3. Okay, now tell me this story. Tell me like this. Think, now we are not selecting. We have given 3 letters ABC. Because like after this process, we have done the selection. So now just think, we are given 3 letters ABC and we are given 3 digits 1, 2, 3. Okay, and I am asking someone, and I'm asking you, okay, the one who is watching the video, and asking to write a password you like using these 3 letters and 3 digits. Like using these six elements, I'm asking you to write a password. Okay, someone may write ACB 213. Someone may write A1 B2 C3. Like that, you can write. We know how many number of passwords. There are 6 different elements. The number of ways that these 6 elements can be rearranged. Is given by factorial 6. What is the theory? We know if we have different R number of elements, the number of ways these R number of elements can be rearranged is factorial R. Using that theory, we get, if we have 6 elements, different elements, the number of ways we can rearrange these 6 elements is factorial 6. That means factorial 6. Okay, here we go. We did the selection. We did selecting 3 letters from P1 and 3 digits from P1. Okay, so after the selection method, now we can get, therefore, number of passwords will be given by, first, how many ways we can select. Okay, the number of ways the selection process can be done. That means the number of ways is 5C3 into 4C3. 5C3 into 4C3. This is the number of selecting ways, the number of selection processes. How many ways we can select 3 letters from P1 and 3 digits from P1 is given by 5C3 into 4C3. But we are asking the number of passwords. I just asked you a couple of minutes ago, if you are given 6 letters, 3 letters and 3 digits, how many passwords can you make? How many passwords can you build? You came up with the answer. We have 6 different elements. So these 6 different elements can be rearranged in a factorial 6 number of ways. So which means I'm asking for the number of passwords. That gives us the number of passwords is given by the number of ways we can select. The number of ways we can select the elements into the number of ways the element with, again, the number of passwords is given by the number of ways we can select the elements into the number of ways the selected elements can be rearranged. The number of passwords is given by the number of ways we can select the elements into the number of ways we can rearrange the selected elements. We have selected 6 elements, so that means factorial 6. It equals, I'll do the simplification in this side. We know 5C3 means factorial 5 divided by factorial 2 into factorial 3. 4C3 means factorial 4 divided by factorial 3 into 1 into factorial 6. So I'll do the simplification. We get, for this, the cutoff 4 remains. This cutoff 4 into 5 remains, because we know factorial 5 means 1 into 2 into 3 into 4 into 5, and factorial 3 means 1 into 2 into 3, that means 1 into 2 into 3 cutoff. And then we get factorial 2 means 2 by 2, and we get 2 into 5 is 10, 10 into 4 is 40. into factorial 6. Factorial 6. Okay. When we come to combinations and permutation lessons, what I tell my students in the class, just keep in mind that we know that factorial 1 is equal to 1, factorial 2 is equal to 2, factorial 3 is equal to 6, factorial 4 is equal to 24, factorial 5 is equal to 120, and factorial 6 is equal to 710. What I tell my students, when we are dealing with combinations and permutation sums, just keep in mind that up to factorial 6, factorial 5 is equal to 120, and factorial 6 is equals to 720. So that makes things easier. So if you don't know this, just pause the video and just note this down. Okay. So I know that factorial 6 is equal to 720. So I get 40 into 720, which gives me the answer 28,800, which gives me the answer 28,800. So the number of passwords is 28,800. Okay. So I'll just tell you in the marking scheme, the A-level marking scheme, how marks are given for these two. Like for selecting 3 letters from P1 and selecting 3 digits from P1, that means for the selection process, they gives us 10 marks. And for number of passwords for writing this method, that means I'll repeat it again. Here this equals the number of ways that we can select the elements into the number of ways the selected elements can be rearranged, and we get 5 marks for this, and for the simplification we get another 5 marks. For the first part of the combinations of permutation sum, they have given 20 marks. Okay. So I'm not giving breaks during my video, so you can just pause in here, and if you have note down anything, just note it down. You pause the video, and I'll just move to the second one. I'll just move to the second method. Okay. And then a quick reminder, I'm not asking you to subscribe my channel, or I'm not asking to click the bell icon. What I'm telling is, just watch this first video till the end, and if you think that okay, what I teach here, you can understand it, and the way I'm teaching is good, and if there are so many past papers you need to get done, you need to get clarified, like something like that, you can just simply subscribe. That means if you can understand what I teach, then only subscribe and click the bell icon and share this among your friends. If not, no need of subscribing, because if you can't understand what I'm teaching, there's no use to you and me of you subscribing the channel. Okay, so I'm not asking you to subscribe till the end of the video. Okay, moving to the second one. In the second one, it is quite different and difficult. They're asking 3 elements are chosen from P1. 3 elements are chosen from P1. And the other 3 elements from P2. 3 elements are chosen from P1 and the other 3 elements from P2. Which make this different and difficult is, like, they are just telling us 3 elements are chosen from P1. But they haven't given us, like, what are the 3 elements? What are the 3 elements we are choosing from P1? What are the 3 elements that are chosen from P1? They haven't given us. So they are only telling us that 3 elements are chosen from P1. So that means the 3 elements can be 3 digits. It can be 3 digits. It can be 2 letters and 1 digit. It can be 1 letter and 2 digits, or it can be 3 digits. So that is why they have made this more complex. They are just telling us 3 elements are chosen from P1, but they haven't exactly specifically given, but what are the 3 elements, which kind of elements are chosen from P1. That means that remains us, like, from P1, the 3 elements we are choosing, we can choose 3 letters, we can choose 2 letters and 1 digit, we can choose 1 letter and 2 digits, and we can choose 3 digits. Okay, so we have to separately find the number of passwords which can be made in this different occasion. We have to find the different number of passwords that can be made in these different number of occasions. Which means if we take 3 letters from P1, how many passwords can we make? If we take 2 letters from P1 and 1 digit, how many passwords can be? if we take one letter from P1 and 2 digits, then how many passwords can make? And if we take no letter from P1, but we only take 3 digits from P1, how many passwords can make? So let's make a small chart. Let's go with P1. Okay, P1. Now I'm not going to simplify this because it can be done by your own. Okay, P1. And this is my chart. This is P1, this is P2. Now I'm writing the passwords. That means the number of passwords. Okay. So first we are thinking from P1, how many letters we are selecting, how many digits we are selecting. From P2, how many letters we are selecting, how many digits we are selecting. Okay. First we'll just write down how many ways this can be done. How many ways by taking 3 elements from P1 and 3 elements from P2. How many? Let's see there's how many ways are there. Okay. Starting from letters. From P1, only 3 elements are allowed to be chosen. I take 3 letters. That means all the 3 elements from P1 are 3 letters. So no digits. Which means when you come to P2, when you come to selecting elements from P2, I know to the password they are only allowed 3 letters and 3 digits. But by now, already I have selected 3 letters. So when considering P2, I can't select a letter. So no letter is selected. But we have to select 3 digits. So 3 digits are selected from P2. 3 digits are selected from P2. Okay, got it. Okay, now I'm going to the second one. That means this is the first way how it can be done. The second way, I'm selecting 2 letters from P1. I'm selecting 2 letters and they're asking us to take 3 elements, and so to the remaining one I'm taking 1 digit. I selected 2 letters. To the remaining one I'm taking 1 digit. Okay, and then come to letters. I know that there should be 3 letters in the password. Already I have selected 2 letters, so I need another letter. From P2, I'm taking that letter. And I have selected already 1 digit, but I know that 3 digits are needed to the password. So I have already selected 1 digit. So from P2, I'm taking 2 digits. Okay, that is the second way. Okay, got it. Now moving to the third one. I'm just selecting 1 letter from P1. But I know that I need to select 3 elements from P1. I have already selected 1 letter. That means I'm taking 2 digits from P1 because I already selected 1 letter from P1. But they are asking us to take 3 elements from P1. That means to the remaining 2, I'm taking 2 digits. Okay, and I have taken 1 letter. When moving to P2, I know the password should be consisted of 3 letters, but I only have selected 1 letter. That means I'm taking 2 letters. Okay, I know the password should be consisted of 3 digits. I have selected only 2, so I'm selecting the last digit from here. From P2, I'm taking 1 digit. So we have 3 ways so far, and moving to the final way. I'm not selecting any letter from P1. That means I have to take 3 elements from P1. All the 3 elements are digits. I take 3 digits. Okay. When moving to P2, I know to the password 3 letters is a must. 3 letters and 3 digits are a must. But I haven't selected any letter from here. So from P2, I have to get all the 3 letters. And I can't take any digit because already 3 digits are selected. Already 3 digits are chosen from P1. Okay, so this is the way how can the passwords the elements for the passwords can be chosen. This is the way. There are 4 number of different ways how elements to the password can be chosen. Okay, I'm just choosing the elements. Okay. Now I'm writing the number of passwords here. Okay, let's go. Now we just did the previous example, so this will be easy. Out of P1, go with me, from P1, I have to select 3 letters. So there are 5 letters in P1. Out of 5, I have to select 3. I know out of 5, the number of ways we can select 3 is 5C3 is 5 out of 3. The number of ways we can select 3 different elements is 5C3 into the next selection process. What is the next selection process? Is digits. From P2, I have to select 3 digits. In P2, there are 4 digits. And out of 4 digits, I have to select 3 digits. Out of 4 digits, I have to select 3 digits. Okay. This ends the selection process. But selecting 3 letters from P1 and selecting 3 digits from P2, this ends the selection process. But I know, as I discussed earlier, as in the previous sum, I'm finding how many passwords can be formed, the number of passwords. So after the selection process, if I have 3 different letters and 3 different digits, that means 6 different elements. By rearranging those 6 different elements, I can make different kind of passwords. Okay, so we have to multiply this by the number of ways 6 different elements can be rearranged. That means factorial 6. Okay, we get it, factorial 6. Okay, then moving on to this one, then I have to select 2 letters. Okay, I have to select 2 letters out from P1. There are 5 letters. Now this is easy, the same method. Out of 5, I have to select 2 letters, and then 1 digit. There are 4 digits. Out of 4 digits, I have to select 1 digit. Done. And then I have to select 1 letter. There are 5 letters here, and out of 5, I have to select 1 letter, and there are 2 digits. There are 4 digits here. From 4, I have to select 2 digits. From 4, I have to select 2 digits. So that means, okay, it is clear. That means it is clear. Look again. 5 letters, I selected 2, 5C2. 4 digits, I selected 1 digit, 4C1. Okay, 5 letters, I selected 1, 5C1 into 4 digits, I selected 2, 4C2. And that even should be multiplied by the number of ways that these different 6 different elements can be rearranged, and it is factorial 6. Okay, then going to the selection process, I have to select 1 letter from 5, that means 5C1. I have to select 2 digits from 4, that means 4C2. I have to select 2 digits from 5, that means 5C2. I have to select 1 digit. I have to select 2 letters from 5, that was 5C2, and I have to select 1 digit from 4, that means 4C1. And this is the selection process, and it should be multiplied by factorial 6 to get the different number of passwords, Okay, then the final one, I have to select 3 digits. There are 4 digits here, that means out of 4, I have to select 3, that gives 4C3 into, and I have to select 5 letters, and I have to select 3 letters out of 5 letters, and I know the number of ways I can select 3 different letters out of 5 means 5C3. And this is the selection process, and it should be multiplied by factorial 6. Okay, you got the idea. So I'm asking how many different number of passwords. That means the sum of 1, 2, 3 and 4, because they are not giving us specifically that what are the elements taken from P1, what are the elements taken from P2. They haven't given us specifically, so we have to find this. To each and every method, a password can be formed by taking 3 elements from P1 and 3 elements from P2, which gives at the end, which gives 3 letters and 3 digits. Okay, so if they gave us specifically like I'm taking 2 letters from P1 and 1 digit, from 2 letters from P1 and 1 digit, and 1 letter from P2 and 2 digits, and that means that is easy. We only have to find this one. If they are asking I'm taking 3 letters from P1 and 3 digits from P2, it is easy. We have to find only this one. But this one, they are not specifically asking, they are not giving us that what are the 3 elements chosen from P1, what are the 3 elements chosen from P2, which means we have to find all these 4 ways. Okay, so then we can write the number of passwords is equal to the number of passwords in 1, in 2, 3 and 4. I'll just write the answer because no need to take time for the simplification. For the first one, I get 28,800. For the second one, I get 864,000. To the third one I get 864,000. Last one I get 28,800. That gives us a sum of 1,785,600. 1,785,600. Okay, that means the sum of this. That means 1,785,600 passwords can be made if we take 3 elements from P1 and 3 elements from P2 at the end, which gives us 3 different letters and 3 digits. So this is how the 2019 A-levels permutations and combinations sum is done. So I hope this is clear with you, and now I'm telling you, if you can understand what I'm telling and what I'm teaching, you can subscribe my channel and then you can share this video among friends. So before you A-levels, I'm trying my best to cover the 2017, 2018 and 18 and 19 papers, both the PU and apply. So I'll be uploading 3 videos in English and single in both mediums. For the same for this one. When I'm uploading this one, I have already uploaded the single one also. Okay, so we'll be uploading 6 videos from when thinking about the language, 6 videos per week, and I'll be trying my best to cover the 2017, 18 and 19 papers before your 2020 A-levels. And even for 2021 students and 22 students, this will be useful for the lessons you have done so far. For a 2021 student, I'll be doing differentiation, I'll be doing straight line, and I'll be doing jointed rods, framework past papers. And for the 2022 ones, it will be useful when I do factor theorem, remainder theorem, when I do trigonometry. So share this with your friends, and I hope this will be useful for you. Okay, then this is the way how the 2019 A-level permutations and combinations sum is done.